rectangles, a rectangle, so Thursday and Friday we talked about parallelograms. Everything that you have for a parallelogram also goes to a rectangle. So where your rectangle is at, we are going to highlight some things. So first off, I do want you to draw this little arrow because we did not put that on our paper. So draw this little arrow. Everything a parallelogram has for the rules also is a rectangle. So you should know the top matches the bottom. The sides match. It's in Friday's bin. There are 2 bins for Friday. So what we're going to add to our picture is that we have 4 right angles. If I say I have a right angle, how much does that make? 90. So we're going to put 90 here. The next one says that the diagonals are congruent. So last time the diagonals bisected each other. Oh my God. The diagonals bisected each other, but they were not congruent. This time, the diagonals are going to be congruent. I know your parallelogram one is not colored. You don't have to color it. Don't worry about it. We're going to color the rectangle. We're also going to add in using our pencil the markings. So the sides match. So I'm going to put 1 tick, which you should know that. The top matches the bottom. Since the diagonals bisect and they are congruent, I'm going to put 3 tick marks on each one of these little pieces. Meaning if I knew one of those pieces were 5, can anybody tell me how much the whole length would be? 10, because you would have to double it, okay? So we're focusing on rectangles for today and tomorrow. So we're done with this piece of paper. Let's go to 64. Can you stop? I can hear you.
It's literally.
I know it's him and you.
I'm not responding.
Okay. So all the properties apply for a parallelogram because a rectangle is technically a parallelogram. We're going to add our 2 new properties. The 2 new properties are that we have 4 right angles. So each corner makes 90 degrees. And then we also know that they bisect, but we're also know that the diagonals are congruent. So I'm going to write the little symbol for congruent. If you want to write the word congruent, you can. So for numero uno, where else can 24 go? On the bottom. Where else can 10 go? Good. Okay, so how much is QR? 10. How much is SR? Good. I don't know SQ. And there's no extra piece of information for SQ. If this is a rectangle with 4 right angles, how could I find the length of the diagonal? The Pythagorean theorem.
I hate that.
Oh my God, guess who's back? Back again. Pythagoras is back. Fellow friend. Okay, so this is a right triangle. Okay. Inside of the rectangle. You should have technically done these kind of problems in middle school, but whatever.
I remember nothing.
I know, you guys don't remember anything. And then you're like, we never learned this. And they definitely taught it to you. So anyways, if I need to find the length of the diagonal, I'm going to make a right triangle. And then I'm going to do the Pythagorean theorem. So 10 is the height. How much is the base? 24. We're going to plug this into the calculator. We are finding the diagonal. The diagonal represents C. So we're doing 10 squared plus 24 squared equals C squared. 10 squared is how much? 100. Number 1. How much is 24 squared? Thank you. If I add them together, that's 676.
What?
Oh my God. 676. Square rooted is how much? 26. So The whole point of this is to find a piece of information and put it in your picture. So what I just found is this whole line is 26. Yes. So technically SQ is 26. PR is 26. QT is how much? 13, because it's half the diagonal. So because it's splitting 26 in half. So try number 2. You're going to move your numbers around to start. 15 can move around to all of the little diagonal pieces. 27 can move to the top.
Is there any decimal?
Yes,
Okay.
there are decimals. When you do the Pythagorean theorem, typically you get a decimal. So don't freak out if you do the Pythagorean theorem, you get a decimal. It was just nice for number 1 that it came out to be a whole number. Do math. It's okay. I know you guys are like addicted. Break the addiction. Break the addiction. You guys are like fiends for your phones. So 27 can go here. And look, you're doing math.
I feel faster.
15 goes there. Where else can 15 go? Good. 15 can go here. 15 can go here. So let's see what we can fill out. So how much is AC? 30. How much is BD? 30. How much is BE? 15. How much is AB? Thanks. BC. Yes. Oh, I highlighted. Okay, so for B, so BC is here. I'm making a right triangle. This is the height of the triangle. This is the base. I have the hypotenuse. How much total is the hypotenuse? 30. You are not just using 15 because you need the entire length of the diagonal. So 15 and 15 is 30. The base is 27. This time I'm trying to find either A or B. C is my hypotenuse, which is 30. So we're going to do 27 squared plus B squared equals 30 squared. So use a calculator and square the numbers.
Number 5. Are we doing the angle or the side?
We're going to do just the sides. Hey, what'd you get?
What?
What'd you get?
Like -5.
What?
What'd you get, Gabby?
13.1.
That's perfect.
Yeah, I have that one down. I did. I got some -5.
So when you square root this, you get this, which is 13. Oh, it's so zoomed in, you can't even see what I'm writing. 13.07. So that 7 is going to make the 0 go up to a 1. So we're going to say 13.1. That's what happens when you pay attention partial of the time.
So basically all you do is minus that amount.
And then square root it. Okay, so what I want you to do, we're going to skip 3 and 4 for just a second. We're not scribbling them out. I want you to try number 5, but number 5 is one of those problems that has measures and angles. So we're going to cross out the angles. We're not going to do the angles. Take a second, put your numbers on your picture for just your sides and see if you can figure out where you need to use Pythagorean theorem. Try to move your numbers around. We're going to do 3 and 4, yeah. I just want to do all the sides first, and then we'll do the angles.
Oh wait, we're not doing the angle in this.
Yeah, we're not doing the angles. Take a second, put your numbers in your picture.
Okay.
All right, all right. All right. That's correct.
We're crossing it off the back.
No. Wish. Next day.
It's like,
Wah-wah.
we're not watching any.
Yes. No. It's not that bad. Just gotta keep moving.
Oh, sorry, I'm like.
Well, how much you put? Okay, but.
W.
No.
Look at Doug is here.
Oh, okay. Why? It's how it's really so.
Yeah.
How do I know which line to do? Like I make look A, B, but it doesn't like really matter.
No, it doesn't matter because the triangles are the same.
42.
So this is what you should have so far. If you at least put your numbers in your picture. 26 can move here. Okay. How much is A to C? 42. How much is E to B? 21.
Oh, shit.
B to C,
46.
26. A to B is your problem. You don't know the bottom, so you don't know the top. You could either make the right triangle from the bottom, or you can make it from the top. It doesn't matter. Either way, you're making a right triangle. I only highlighted AB because that's what I'm trying to find. It's still a right triangle, just upside down, but it doesn't matter because it's symmetric. So it's the same triangle at the bottom. The height of the triangle is 26. The hypotenuse is 42. So you're trying to find A or B. So this is a subtraction problem. So I'm going to call it B. So we're doing 26 to the power 2 plus B to the power 2 equals 42 to the power of 2. So take a second, square your numbers. You're going to have to minus them. What'd you get?
He did help me, but.
That's good. You're supposed to help each other. Y'all just be letting your partners drown in the math.
That's all it is. What do you like, leaving me in the dust and stuff? I'm like, you never be no.
Because he knows you don't cry fully.
Yeah, I do. I'm over there. What's like? Last week. But you're doing it. Yes. Oh, I look at how it's sound like. I never want to hear us. I get never against. And what was the bar of the lot?
When you minus them, you should get 1088. When you shift square root, you should get 32.98. The 8's going to make the 9 go to 10, which is going to make the 32 go to what? 33. So, do we feel okay? Okay. We are going to do the angles now. So the sides are pretty basic. The sides match. We are doing the angles for 3 and 4. I'm trying to find a YouTube video right now. Don't you see the red square?
Oh, you're
Oh, yeah. Yeah.
On the screen.
Okay, anyways, so just like last week where the parallelogram was at, I never do it during this class. I always do it earlier, but I forgot to do it earlier. So 27 needs to move, just like in a parallelogram, it has to jump across. So where can it go?
Right here.
Yes, in this bottom corner. So if it was at the top, it jumps across the transversal to the bottom. Does anybody see where else 27 can technically go?
Across from.
Right here. Stop.
What?
And then here.
Go ahead, we'll ask.
No.
Again.
The reason why you could do that is because this is technically an isosceles triangle. So when the sides match, the base angles match. So not 54. If a corner makes 90 in total, 27 plus what makes 90?
63.
63. Right? Okay. Where else can 63 go?
Opposite side.
Opposite side. 63 can also go right above it. Because each corner makes 90. Now let's go back to this triangle. If this is a triangle, and I'm looking at 27 and 27 and where the N is at, how do I figure out this big angle right here if it's a triangle?
Or no, add 27, 27, subtract 180.
Perfect, because a triangle needs to add to make 180. So if this is 27 and this is 27, I'm not going to show the work for this.
126.
126. So 126 can go here. Where else can 126 go? Right above it, because from chapter 2, vertical angles are congruent. If I look at the other triangle, I have 63, 63. How much is the missing angle in this triangle? 54. Okay. Most of you have really good like problem solving abilities and can fill out these numbers once you get going and we do a couple examples, but then you don't know how to read this. If you cannot read this, you will fail the EOC
I'm failing.
because all of this, remember you need algebra 1 to graduate. Did you pass algebra 1? Okay, good. At least you did that.
If he didn't pass algebra 1, he died.
You would need fast geometry. So if you have J in the middle, remember it's focused on J. You're going from M to J to K. How much total is this? 90.
Oh, yeah.
Because it's the outside letters. We're going to do another one. It's still focused on J, so we're still in this corner, but it says MJL. 63. Try to see if you could find the last 3 angles. Focus on the middle letter, but it's either the whole corner, the little piece, or the bigger piece. All 3 of them. How much do we think JKL is? Or JLK?
I'm
63. How much is KML? 27. And then MNL. 126. Nice. They don't, they can't really hear you, but they hear me keep saying,
Can you hear me?
no. You're sitting too far away.
Bathroom?
Yes. Okay. For number 4, it's the same process. Now, we're only given one angle. 64 can move to one other spot. Where else can 64 go?
Right below.
It's right below it. Vertical angles are congruent, so I can move 64 right here. Think about this is a triangle. The bottom angles need to match to make 180. You only know the top angle of the triangle. So what would I do to find the missing bottom angles of the triangle? Good. We subtract it from 180 and we divide by 2 because there's 2 angles. So if I take 180 and I'm minus 64 and I divide by 2, how much is each corner? So if I take 180 minus 64, how much do I get? 116, but that's between the 2 angles. So how much is each
58.
angle? 58. Because you have to divide by 2. So take a second, see if you can move all the 58s around. Each corner needs to total to make 90. Don't really need to show the work for this. It's just like putting numbers in a picture. Like problem solving. The puzzle. You're going to have many problems in your life. Geometry should be the least of your problems. Or the most.
My problems.
Each corner should total to make 90. So you should be minusing from 90.
Right this.
Yeah, that's perfect. You have one last angle you need to find. So in each triangle is 180 in total. So now that you know the two base angles, you can find the last angle in the triangle by subtracting from 90. So how much should be next to 58?
32.
32, 32, 32, 32, 58, 58. How much is the last angle in the blue triangle? What is it? 116? 116. So now that we have our numbers, see if you can read the 3-letter angles. We'll do the first two together. It says X, W, Y. It's focused on W, so I'm in this corner. But I'm starting at X, I'm going to W, and I'm ending at Y. So how much is that corner?
58.
58. The next one is focused on X, so that's this corner. But I'm starting at Y, going to X, and ending at Z. 32. See if you could fill out the last 3 angles.
Yeah. Like turn it on.
How much is WVZ?
Is it 32?
Nope, because it's focused on B. 116. The next one's focused on W, but it says X, WZ, 90, and then X, ZY.
Is it
58.
90 because it's out?
No, because it's X, Z, Y, so it's just this corner. Because you cut across. Yes, because it's the outside letters, so it's the whole corner. So if it's the outside letters, it's the whole outside, so 90. If it's cutting through, that's when you have to look at the inside, either the little piece or the little piece. You have to decide which one's in the angle that's forming. So we're going to set up 2 problems on the back, and then you can use the last 15 minutes to work on them. So we're going to set up the angle problems because the sides are obviously like they're equal to each other. Like it's pretty basic. Okay. The angles are the weirdos. So we're going to do the bottom 2 because those are the hardest on the paper. That's why they're at the bottom. So let's set up the bottom 2. So now for 12, do these angles look the same?
No.
No, they're not. What should I do?
Add equal to what?
Not to make 180, 90. Because if I jump across the transversal, this one can go here. And then they're in the corner together. The corner total makes 90. So we're going to add to make 90. So we're going to combine like terms. 5x and 1x makes 6x. -8 and 20 make 12. 2-step equation. So what do we get for x?
There's no paper online.
Line?
Front and the back?
No, just back. Where should I plug this into?
Right here.
Nope. It says X, Z, W. So it's talking about this corner here.
Other corner.
Yeah, so stop talking then.
That's not mine.
Well, if you weren't annoying.
Yeah, at least I'm trying to work.
That's true.
No, I just want to try and.
13, let's set up 13. These are the 2 hardest on here. So 13, look at your problem. They are not in the same triangle together. Yeah. No. That means you did it wrong. Anybody have any thoughts or ideas of what I could do?
You look.
Okay. I could, are you talking about the 5x plus 7 or the 134? Okay, so you can put it in the opposite corner here. You put the 134 down. Good.
Fact 180.
Yes.
Also, you could.
Yes. Are you talking about finding this angle right here? Yeah. So what he's saying is that, and there's like a bunch of different ways to do this. Okay. So this is one way to do the problem. So if that triangle is 134, just like we did on the front, if I minus 134 from 180 and I divide by 2, how much is each corner? If I minus from 180 and I divide by 2, how much is each corner?
123.
23. And then if I minus 90 and 23, this is 67. So what could I do with 67? Equal it to 5x plus 7. Because each corner makes 90. So once I get 23, I'm doing 90 minus 23. So minus 7, divide by 5. There's a bunch of ways to do these. That's literally, that's a different way that I did all day today. Other classes chose to do it. Yep. So if you work backwards, the harder ones are 10 and 11 because they're the angle problems. If you want to start with the easy ones, start with 6. You have 6 problems. Yep. Which one?
Oh, no.